calculating the surface temperature of the Sun. Let U of open paren lambda T close paren be the energy density as a function of wavelength and temperature, and denote emissive power by E of open paren lambda T close paren, then we know that, see the equation, and that total radiation energy per unit volume is, see the next equation. So we have, see the equation, for the total rate of radiation per unit area of a BB. If the Sun is overhead at Earth, we have radiation emission from Sun as BB at temp T, where the emission energy is related to T by above to give
E sub sun of open brace pi r sub sun squared close brace times open paren unit times area over 4 pi d sub sun minus E of ARTH squared close paren equals E sub earth goes to E sub sun equals the fraction with numerator r sub sun squared and denominator for d sub sun minus E of ARTH squared E sub earth. Thus, an observation at Earth of energy falling per unit area of, see the next equation, indicates an emission rate at the Sun's surface, per unit r of, see the equation. If we now use the relation E of open paren lambda, T close paren equals C over 4 times open paren AT to the 4th power close paren, we obtain for temperature at the surface of the Sun. See the next equation.